Hey, we're live in AP Calculus class today. It's 12:09, and we're going to do 154 and 155 right now together. You guys ready? I'm going to turn around and face away from the camera. All right, here we go. I'm going to make this full screen, too, so we can all see it, since we're all here. I'm a pro at this. Full screen. There we go. All right, so we're going to sketch and graph and write the equation of line tangent to the curve of this original y equals thing at x equals 3. Let me get out of the way of calculator cam there. And then locate another point on the curve with the same slope as the tangent. That's a lot to do in this one problem. So let's just break. Fortunately, the things we need to do are pretty straightforward. As far as writing the equation of a line tangent to a curve, that's going to require a thing we already did, well, you will already do in question 152, basically the same process. So we're going to use the point-slope form to figure out what's going to happen at x equals 3. Point-slope form is going to look like this: y minus f of a equals f prime of a times x minus a. Just point slope form from back in the day. In this case, we're kind of told that a is 3, but we still need a few other pieces of information. We need to know what f of 3 is, or I guess what would happen if we plug 3 into x, and we also need to know what f prime of 3 is also. So let's go ahead and work on those things. First thing we need to know is, what is y when x is 3? So we'll plug in 3 times the cube root of 3 minus 2, just subbing in our given a value right there into our equation. 3 minus 2 is 1, the cube root of 1 is 1, and 3 times 1 is 3, so y equals 3 is on this. So the point that's on the original curve that we're looking for a tangent line for is the point 3, 3. That's the point. To find the slope, we're going to need to use y prime. And for that, I think it's probably a good idea for us to actually take the original function and maybe rewrite it as a polynomial. It would be better to think about it as y equals 3 times, in parentheses, x minus 2 to the 1/3 power. Because now we can just use the power rule. So y prime will equal, well, look at that. The 1/3 comes down, cancels out with the 3. The x minus 2 will stay right where it is, but we have to drop the 1/3 down 1 degree to negative 2/3. So our y prime will be 1 over the cube root of x minus 2 squared. Two different ways to write the same thing. That's kind of complicated, but before you panic too much, we just need to know what y prime is when x is 3, which will be really easy to do because the same kind of things will happen. 3 minus 2 is 1. 1 squared is 1, cube root of 1 is 1, so here's some notation for you. Y prime when x equals 3. Big vertical line, and then this is evaluating what y prime is when x is 3. You don't need to know this notation, but it is helpful sometimes. This would just be 1 over the cube root of 3 minus 2, which is 1 squared. It's just going to be 1 when you're all shaken out. So this becomes kind of an old Algebra 1 problem. We're going through the point 3, 3, which is on the original curve, and we know the slope at that point is 1. So the equation would look something like this. It would be y minus 3 equals 1 times x minus 3. And this one is so easy to put in slope-intercept form, so we might as well just do that. It'd be y minus 3 equals x minus 3, and we just add 3 to both sides, y equals x. Look at that, that's nice. Simple. So as far as that part of the problem goes, we have, let's see, we read the instructions. We haven't sketched the graph, but we have written the equation of the line tangent to the curve. What we got to do now is locate another point on the curve with the same slope as that tangent line. So we're looking for another point that also has a slope of positive 1. This might be a good time to bring out the calculator so we can get a good look at what the original graph looks like. So I'm going to do that over here. I'm going to bring calculator cam to the forefront, but I got to do this first. So our original function, let's see, calculator on. I got to boot up my, there we go. So the original function is 3 times the cube root of x minus 3. I'm just going to graph that on a standard graph, too. There we go. Looks something like that. Is that correct? Oh, it's x minus 2. Okay. I was confused for a minute because I was looking at that graph and I was like, no, that doesn't have the right coordinates on it. There we go. It's going to just move one space to the right. That's better. That's like a stat plot that I don't know how to turn off. I like keep looking on how to fix it. So what's going on, I'll just point to the point on the camera. What's going on right now is that we just figured out in the last part of the problem that there's a point right there at 3, 3. And actually, if we graph the line y equals x, which is the line that we've kind of found, that's going to be directly tangent to that curve right there. Beautiful. So as part of this problem, we should sketch what we've got right there on the graph. I'm just going to do that underneath calculator cam, and then I'll get the window out of the way. So our original graph is going to look something like that. It's a cube root of x graph. It goes through the point 0, -4 about. Has a vertical tangent at 2. And right at the point 3, 3, there is a tangent line that has the equation y equals x. So this is kind of what my sketch looks like. I'm just doing a rough cut to graph that line, just like that. The other part of the problem that we're asked to do is to find another point where we would have that same slope. You can kind of see it if you start like, I don't know, if you take like a ruler or something and you make a little slope line like this. If you were to take that ruler and drag it down here, you can see it's going to be kind of right about there. It's actually going to be pretty easy to find, and I'll show you how. Because basically here's the thing we're trying to solve. We need the derivative, we need y prime to equal 1. Because we're looking for where the slope of the original graph is 1. And y prime is the slope of the original graph. Not only that, we have a pretty easy formula for it. We're looking for when 1 over the cube root of x minus 2 squared would equal 1. This is one of those algebra problems that's probably easier to solve if we just kind of think about it for a minute rather than trying to do like steps for it. I mean, if you did want to do algebra steps, what you could do is you could flip both sides of the equation. Since the right side of the equation is just 1 over 1, you could really just think about it as the cube root of x minus 2 squared equals 1. You could even cube both sides and ignore the cube root and then solve this problem. X minus 2 squared equals 1. And when you take the square root to solve this, what you have to remember is there's kind of a plus and minus thing going on right there too. Basically what it shakes out to be is that x minus 2 has to be either plus or minus 1. Because both of those things, when you square them, will be positive 1. We already know this happens when x is 3, because we solved that as part of the first problem. So what about the negative 1? That's really what we're answering here. And that happens when x is 1. And you can kind of see that even on the sketch of the graph that we made, that there's kind of the point right about there when x is 1 is the other spot where the graph will also have a slope of positive 1. Did they ask us for the full point or just located? They did ask us for the full point, so we also have to take that x equals 1 and plug it into the original equation. So y has to equal 3 times the cube root of 1 minus 2, which would just be negative 3. Because 1 minus 2 would be negative 1. Cube root of negative 1 is negative 1. Negative 1 times 3 is negative 3. So the other point, I suppose, is 1, negative 3. I considered leaving this question off the set because I knew it would take a long time to do. Look at that timing. Beautiful. Hey, we'll see you in the next video.